The introduction slides. Like I said, I'm going to add to and create more, make this kind of a working document. I've always had the sense or the feeling that everybody should know all of this stuff on the first night of class, and then I find out maybe one or two, or nobody, or I'm the only one kind of talking to myself with the all of this information. So that we all start off on the same plane, give you a chance to ask questions. You do the foundation material, common or not so common knowledge. Every shop, every industry has its cultural knowledge, the tribal knowledge of we've worked here long enough, we've done that job enough, this is the way you do it. Every other way we've tried it has resulted in not so good results. This is what we do. You don't learn that until you screwed up the first one and then got the talking to. Because then you're part of the club and they can share with you. Up to that point, I want to share up front and make sure that we're in that group. All right, so I've been kind of going back and forth on the machining bias, or might even just say industry bias. So our agenda, I want to cover tools, work holding, speeds and feeds, give you some resources, machine operations and tooling, our MOT, set up and run, and then as we go through the class and I find videos and other cool things, the cookbook of programming. So give you recipes of, in these situations we do this, or at the very least, we're always going to establish this, then do this, then this, and then whatever else that part has to make a prismatic shape. All right, so my machining bias is, as you read down through these, some of them are going to go, ooh, and some, that's a terrible machine. I was always taught that anybody can make good parts on a new machine. Machinists can make parts on any machine. If it is able to run and hold a reasonable amount of tolerances and repeat, doesn't matter how poorly the machine has been maintained. That should be your first job, is to bring it up to speed. But at the end of the day, you should be able to make parts on any machine. So same with the tooling. Is some of these you're going to go through and I don't like those tools. I've used those on this. Well, in that application, yeah, they were probably terrible. Grade of carbide, coatings, tolerances on the tools. Just a matter of how they ground the relief for that material is terrible. But that doesn't mean that the next job is going to be the same. So more so, I would see that bias in software. So like we were saying earlier, Mastercam, CamWorks, which is also SolidWorks Cam, SolidCam, pluses and minuses to everything, HSM and Cam for Fusion 360, SurfCam, FeatureCam, and if anybody's ever seen Bobcat Cam at West Tech or any of the trade shows, it has actually gotten pretty good, but they have such a reputation. They have such a bias to them now of the way that they presented themselves in industry and the way that is kind of marketed, that there are companies that are using Bobcat, but not as many as could be. And then same with SolidWorks, CATIA, Inventor Fusion 360, Pro E. Always look back on the Pro E guy that said, "Oh, SolidWorks will never amount to nothing." I was like, yeah, in 2 or 3 years, SolidWorks is eating your lunch. So the next best thing is right around the corner. I didn't put Onshape. Fusion 360s in here. I should add Onshape real quick. Again, those cloud, I think industry is going to gradually adopt and become, some industries, aerospace, really tight security, mil spec type stuff, won't ever be on the cloud. It's just too much exposure. But and most run-of-the-mill industries where you want to take advantage of those resources, the security is high enough to cover. So everybody has their preferences. Try to identify those biases, those preferences before they become your sole train of thought. All right, and then each of these brands, an emotional response. They're just brands. And like I said, the softwares on the modeling side, the 3D modeling side, they're reaching convergence. They're more the same than they are different. The way that you get there, the way you go through the maze, is a little bit different, but the end result is very, very much the same. Right? For the tooling, We're going to just talk in general terms about the drills, jobber, screw machine, extended parabolic, reamers, taps. I did not get the pictures of the reamer. I need to find the big honking, like 3-inch reamer. Facing, roughing, finishing, tapers, insert and thread mills, form tools. Consider the mill drill, roundovers, T-slots, slitting, convex, concaves. Anything that is not your standard end mill kind of goes into that form tool. If I would have to draw it to get its profile to recognize geometry in the CAM program, it's a form tool. All right, so categories and descriptions, a lot of information, again, with that cultural knowledge. And a lot of these tools, when we talk about lengths of cut, when we talk about diameters, reliefs, neck downs, specific geometry of that tool, we're opening up, we're going to MSC Direct. We're going to your favorite tool supplier, and we're going to search for that tool and look for its specifications. And then we'll know that a 1/2-inch 3-flute, 4-flute carbide from AccuPro, maybe 1 inch, but from Hurdle it's 1 1/4 inches. Generally accepted, it's 1 1/4 inches. Well, I've run enough of them that I'm going to think it's 1 1/4 inches till I pick one up and actually measure it at 1 inch. Right, but there are variations in tool lengths, and you're always going to need to verify it in the setup. All right, so a lot of these we'll take care of in the MOT, and we're looking specifically at the characteristics, the material, high-speed steel, carbide, coatings, number of flutes, diameter. We were just talking about length of cut. So on the drill lengths, starting at the top, the screw machine length, longer lengths, less rigid. You're going to have more chatter, going to be less engagement that you can take. Jobber length, and then the extended all the way up to probably whatever length you want to deal with. See if we can get through the tools, and we'll save the work holding for next time. The two drills, so on the left is the twist, on the right is parabolic. I need to get a little better picture with those side by side. This has a little bit more angle in the helix and slightly different tip geometry. So where the standard twist drill is going to be about 1 times D at its max, the parabolic, depending on the manufacturer, is going to say 1 to 7 times the diameter of the tool for the pecs. All right, so I can start off heavy, and this will eject the chip. Where this will kind of weld up and clog up the flutes, whatever this geometry. So in a production environment, where I'm watching this one on a 40-second cycle time, I'm probably going to shove this drill in there in about 10 or 15 seconds. All right, if I'm looking for seconds because that machine is only ever going to run that one part, and seconds over the course of years become days, if not months, we're going to look for every second we can get. On the taps, the fast spiral bottom, fast spiral standard end, tin-coated spiral point, bright finish or standard spiral point, and then the roll form taps. All right, a couple of comments is the fast spiral taps, the chip is going to go up. They can still catch and they can still break. Of course, the difference between the spiral point tap, we had a 1032 that we ran, 100, 120 parts on before it broke. The spiral, fast spiral was closer to 250. And then we come over to the thread form, which is now run about 1,000 parts or close to 4,000 holes. And, it's still going. All right, but the issues become, the resistance at the cutting edge. The roll form tap displaces the material. So my last comment, technically it's a stronger thread because it's not shearing the material. But because the tap drill is a larger, minor diameter, and then it displaces into that material, you can't gauge it the same way that you can a spiral point. So aerospace, a lot of mil-spec won't allow thread forms. All right, it's just not inspectable. And then with the spiral points, we're always going to talk about pack up. All right, as the chip pushes ahead of the tap, that on a blind hole, and we get to a certain point where that chip cannot compress anymore, and then it's going to break the tap. It's the same as just hitting the bottom of the hole. There's no place left for it to go. So we're always leaving that little bit of room, and then accounting for we're going to have to clean that out. One of the problems with the CNC is that we're really not pec tapping per se. It can, but it's it's kind of a pain. Pec tapping would be go in a little bit, come back out, go in a little bit, come back out. It doesn't do that very easily. Most of the time we're driving to a depth, coming back out, and then relying on a secondary, a finishing operation to come back, tap it to depth. All right, so all considerations. These are all high-speed steel. So Ski Cut has a 45-degree helix. And we'll go just a little bit longer, and then we'll wrap this up. So even at high-speed steel, this is going to eject the chip in aluminum a lot more efficiently. The roughing tools, again, a lot of material. And the thing of note is when you see that little circle at the center, basically the center where it was ground, that is not going to be a center cutting tool. I cannot plunge that. The tools that come with the flutes to the centers, I'm going to be able to treat those as a drill and actually get some plunge or some ramp lead into my operations. And then these are all 3/8 tools, so this is a kind of an extended flute length. And I couldn't remember if this was stub or standard, but it's probably closer to standard. All right, so high-speed steels available in a variety of geometries, probably more sizes than the carbides. They just don't have the rigidity or the temperature range. And then we'll come over to the fly cutting and the facing. All right, so single point with a lathe bit, single point with an insert. This one's called a B52. We've had really good luck. Leaves a beautiful finish. And we get these in different sizes. So I think I have the 3, the 5, and the 7. And can get that nice rainbow mirror finish out of a piece of aluminum. And for the most part, we run a lot of aluminum, so that's kind of our first. We'll talk about the steels and the harder materials as we go. So let's see, consistent cut balance. All right, so and then the insert cutting for the face mill. So I think this one is either a 4 or 4.5. So it's a pretty heavy tool. You get into that heavy of a tool, then you start having to take into consideration, especially for the side mounts. As fast as those side mounts whip around now, that'll actually throw that, a 8 or 10 pound tool. I think we measured that one at like 10.5 pounds. It'll throw it out of the arc. Umbrellas, then get that size, we're worried about hitting the tool next to it. So still have some considerations on tool selection, how it's going to fit in the machine. And then the Weldon Ski Carb, which they don't, they make them, but instead of a $300 tool, it's now a $600 tool. This Ski Carb is coming up on either 15, 20 years old, probably old enough to drink. But it has a lot of wear on it, and it's one of those tools, the duller it gets, the nicer the finish it leaves. And the OSG 3-flute 10-coated, again, rigidity, having the shorter flute lengths, we're going to be able to push that tool a little bit harder and make those adjustments. And then the other difference between the fixed holder, so the set screw coming in from the side is basically side loading the tool. That little bit of clearance, millionths, tenths difference between the shank of the end mill and the clearance on that fixed. We're side loading it. We're not perfectly concentric. We're going to inject a little bit of run out in that tool. The ERs are going to technically have perfect run out, a couple tenths at most. But under an aggressive cut, we've had tools pull out of the ER collets. We're running all-tin coated half-inch roughing tools in 4130. It was 4130 anyway. 43, 40 now. Anyway, preheat treated about 40 to 45 Rockwell. And that tool came around, all of a sudden I was like, well, that's a really weird noise. It's cutting through the top of the vise job because every one of those passes, it pulled a little bit more of the tool out each time around. So ERs have their limitation. Every holder is going to have its limitation. And then we have the tool set. So again, the 3/4 inch Ski Carb extended length. So we have kind of a truncated flute length. So we can keep the rigidity up. It's still going to chatter because it's a long tool. I need to find the chart because there was a comparison that a company did for different lengths, and it was kind of surprising how much variation they had in lengths, just where it landed in the harmonics. So ball end mill, also truncated, 1/4 inch ball end mill, a little bit shorter, 1/8 inch, a little bit shorter, and then we come over to the lollipop cutter, or 270 degrees of cut. So this one was actually able to undercut on this this brace mold. So the 1/8 inch tool was about, I don't know, an hour and a half of back and forth to get the nice finish down inside of that slot, with a 1/16 radius at the center. And then the undercut was just calculated out to where the shrink of the material on that length was about 35 to 40 thousandths. So even though this is our negative clearance, once the material shrank, popped right out of the mold. Missed close. Some wood tools. Keep in mind that Mastercam also programs for routers. So I will bring in the other slideshow of my 2 years at Thornwood Furniture Manufacturing, where we ran a lot of these tools. So the brad points, strange looking tools, single flute spiral. Single flute, I need to get a close up of that one because it's really cool. Single flute tools, down shear, up shear, down shear, and then in comparison, standard down shear end mill. You may have only ever seen what we would consider the standard end mill. The up shear is weird because in conventional style cutting, its tool pressure is still pushing down on the part. Go figure. It works in wood. I haven't ever touched one in metal. All right, the drill mills, again, need a little better picture, but basically an end mill with a 90-degree point. Great for chamfering, spotting, and a little bit of engraving. The saws, we have the T-slot cutters, slitting, and jeweler's saw. So when you don't have an arbor for a jeweler's saw, you chuck one up in the lathe and you make one. All right, so yeah, basically just mild steel and enough to go through, and we're making little grippers for the robots, and it needed about a dozen of those little, I think that was about 20,000, so 1/2 millimeter slots on the face of the gripper. And then thread milling, we can do helical interpolation. I will go steal a picture of the multi-tip thread mills. Advantage of the multi is that in a couple passes you get the same result as making a bunch of passes in the single point. Advantage of the single point is it's not pitch dependent. So I can do just about any, as long as I can get to the root of the thread, we're going to be able to make that thread. Multi-step reamer, these were probably for the wood as well. The clearance for number 10 with the countersink on the end of it, grounded in the end of it. So as long as we had the clearance, not drilling into the bed or into the vacuum pods, we could go through and drill and countersink in one shot. And then our drill chucks, so the keyless, I prefer the key, or the key to the keyless in the higher RPM spindles. By the micro, and then the keyless. Problem with the keyless is I've had it on drill bits actually loosen up as the regenerative braking was regenerative braking, and it kind of untorqued itself, and all of a sudden, there goes the drill bit. Right. So on the other hand, I don't want to take a $300 Obrec on a $120 Cat 40 and the spanner wrench and have to wrench on it every time. So the keyless, at least, if we tighten on 2 of the 3, I haven't ever had a keyless back out on the regenerative braking. So I will, the 1 or 2 times the power went out and we were running at 10,000 RPM, and 20 minutes later the spindle was still winding down to a stop. That regenerative braking is doing quite a bit. All right, the ER collets. What are the other? There's the other styles. Tend to stay with the ER. So the 32 is the bigger, and this will go from 16th to about 3/4 or 19 millimeter to about 19 millimeters. Again, the fixed chuck with the pull studs. Pull studs are machine dependent. I will find I've had 3 pull studs break, crack, or otherwise fracture. Only one was in the machine, dropping a $200 cutter while it bounced off the table and onto the way it covers and then off on and didn't break the tool. These are considered consumable items. They should be replaced every 2 to 5 years. I don't think I've ever replaced except the ones that are breaking, so that's on me. And then the ER16 is about a 30-second, all the way up to 10 millimeter, 3/8 10 millimeter. All right, so the point of the tools, and like I said, we'll get into work holding next time. Point of the tools is there's a lot of money sitting there. You go out to buy a machine, you price a VF2 at $50,000-$60,000, and then you put 3 vices on it, 2 or 3 vices, so that you can cover multiple production operations. Each one of the tool holders is $100 to $150. Each drill chuck $120 to $150. All of a sudden, you're looking at $4,000 to $5,000 of tooling. Oh, and we haven't even put the tools in it yet. Then I said 2 or 3, probably at least $2,400, $2,500 in vices. All of a sudden, your $60,000 machine is $70,000, and you still haven't bought the computer to run the software. The $5,000. I think most of the CAM packages still hover around $5,000. And, before you know it, you're at $100,000. So companies are making big investments, right? So it's to your advantage to be that meticulous OCD. I joke about my OCD, but I'm completely OCD. When something breaks, when it doesn't do exactly what I expect it to do, I'm in analysis mode. I want to know why. I don't want it to ever do it again. Even though I know it's going to do it again, I got to get over it. We want to preserve these tools, and we want to preserve and be the most efficient. So on the work holding side, we'll pick that up next time. If you have questions, stick around, but we're good for lab tonight. Like I said, the first couple of weeks is getting into the mode, kind of getting some of this foundation material out of the way. I said this document's going to be available, so if you have something cool, add a slide to it and throw in a picture, make a comment. Want this to be a working document for the class. And we'll build on it, have a reference. So, you're working on an assignment or something. What was, talking about for that particular tool? You can come back to it and reference it. Yes.
Is this slide on Canvas, or how do you?
Yeah, this is in Canvas, and it is introduction slides.
Yeah, it doesn't give us permission. You have to request it.
Okay, so it's on my Mesa account. All right, so if you've requested permission, I will do that as soon as we get a break here. I had to share the master cam over to from my Mesa account over to my Maricopa, and then why they're in separate domains, I don't know. I got to get you in the same domain, and then you'll be able to launch it. So I apologize for that. I didn't realize it wasn't loading. Yes.
So would you recommend downloading that software, even though you can't generate code for it?
Yeah.
Could you do the program in there and then generate the code here?
Yeah.
Oh.
We will have to verify that against the software that's installed.
Oh.
But it will read in past versions, our education license was able to read the MCX file and produce code with it.
If we stay at 19, we're not going to be able to take.
Well,
sorry, if we stay at 18, we're not going to be able to download 19 and migrate.
Well, my 18 expired. So my demo HLE ran out on July 31st. So I think I'm pretty sure what Mastercam does is from August 1st to July 31st, that's your window to do 2019. If 2020 comes out, it'll be this plus, and then over to July 31st of 2021. All right, so you got a little bit of overlap there to where you're not constantly loading software, but we need to kind of verify some of those.
And I know MLC has a 2020 kickoff.
Right.
Yeah.
Yeah, the event. And I sent John a nice email and said, thank you for holding it on my first night of lab, and you guys never want me to come anyway, so that must be your excuse. No.
You said it's okay to miss lab.
Yes, if you're going to go to that, yeah, definitely. And again, would like everybody here for the face-to-face, but I understand work and other obligations. Make sure you're watching the videos, you're emailing for questions, you're getting those questions answered. So the Thursday lab is optional. If you have questions, that's your time to come in, make contact, get your questions answered. So, I tell the SolidWorks classes, do not suffer in silence. I can't help you if I don't know what the problem is. All right. Usually it will piss you off that I'll sit down with you for 5 minutes and, okay, this is what we're doing. This is the logic behind it. This is what we need. And look at that. Instructor presence required at work. Yeah, most of the time it's something simple. There's a few times where I've gone, I don't know why I did that. And we have to figure out the workaround. But for the most part, we're going to be able to go through most of these operations. And if you have a hairy, scary part from work that isn't under non-disclosure, non-compete, or something else, bring it in. We'll take a look at it. All right, either as one-on-one, or if you want to put it in front of the class, we'll take a look at it. All right, we'll call that good for tonight, and stick